Tom Markiewicz is a developer advocate for IBM, where he specializes in iOS, Swift, and machine learning with Watson. He recently wrote a book called Getting Started with Artificial Intelligence, and is currently building a Coursera course on machine learning with iOS.
Thank you. Yeah, welcome everyone. My name is Tom Markiewicz, as mentioned. I'm a developer advocate with IBM. One of the things I recently wrote a book on is getting started with AI and how to get started, specifically as a developer with building enterprise applications using AI. And so one of the things that is a theme in this talk today that we want to talk about is both looking at machine learning and AI from more of a getting started and beginner point of view, and transitioning that in to the recently announced partnership that IBM has with Apple and their CoreML. And so I'm going to be covering a lot of topics, a little bit more at a high level. And then I'm going to be handing it off to Devin, Conley, who is a lead engineer on the actual integration with Apple CoreML and Watson. So one of the things that we all really know, between congestion, interference, dead zones, just problems with our cell phone connection, we all know the pain of how bad mobile data can be still in 2018. It's not very reliable most of the time. But when it comes to just personal web browsing, sending text messages, surfing on Facebook, it's not really a big deal. It's an inconvenience, but it's not the end of the world. But when we look at business applications, the stakes are much higher. We're talking about jobs being impacted and real money being lost or wasted when a lot of different industries, people cannot do the work that they need to do. So let's take a look at a specific kind of quick example just to illustrate this. Imagine you're an airline mechanic. You're on the tarmac. You're trying to identify an issue with the airplane. Hundreds of people on the plane are all grouchy and mad. Not a great situation. They're under a lot of pressure from all angles. They need to be able to go in, take a picture of the problem, take a picture of the part, be able to identify it, possibly pull up a manual, or get that new part ordered as fast as possible. So they need to just be able to pull out that iPhone on the spot and take care of it. And if the internet connection is bad, that makes that really hard, if not impossible. And as the day goes on, as the weeks go on, how are they then able to update the model that they have that is used to be able to identify these parts? That's the kind of a core problem that we're talking about here and that needs to be solved. How can we allow people that work in all different kind of industries to be able to be mobile, and when they have limited connectivity and can't afford to be taking time, they need speed, what can we do? How can we help that out? So, that's just one common problem. We see this in a lot of different industries. But the big problem that we see today is that, especially in business, the amount of unstructured data that is being generated is just enormous. So you can see from this data that 90% of the world's data, they say has been created in the last 2 years. And then 80% of that is unstructured. So what are we talking about here? Well, we're talking about valuable insights that can be hidden in emails, customer support discussions, reports, tables within PDF. You don't have a way to get to that very easy. And this is a problem that faces not just large enterprises, but it's also small companies, it's also startups. So when you're able to harness all this information, when you're able to dive in and get some insights out of this unstructured data, that's really where the possibilities are endless for businesses to be able to extract that and use it in a lot of different ways. And so, it kind of begs the question, well, how do we do that? Well, that's what, we're here to talk about. Machine learning is one of the ways, the primary ways, that we can, try and avoid these problems. But I do want to just step back for a second and just talk at a high level about AI. I know if I asked you, everybody has heard of AI, everybody has heard all the buzzwords, machine learning, deep learning, this algorithm, this model, but behind all the buzzwords, behind all of the terms that we hear, I think it's easy just to kind of forget and be skeptical a little bit, but actually AI is so pervasive right now between IoT, home devices, commercial robots, industrial robots, all our applications, autonomous vehicles. It's being used everywhere. And I think it's important to kind of step back and talk a minute about AI winters. And this is kind of, I think, an interesting concept to understand because AI was initially started back in the 50s. So why is it that we've had essentially versions or research into this technology for, let's say, the last 70 years, but really we're only seeing a huge explosion right now? And this is what they refer to as an AI winter. Essentially, there have been a few periods in time over these past 70 years where the excitement has been really high, the enthusiasm has been there, there's been a lot of effort into the research, and a lot of hype got built up around AI, but the results never materialized. We weren't able to build applications properly. Anything that came out of it just kind of fizzled, and then due to that disappointment, the funding dried up, the excitement dried up, and it just kind of died off. So these periods of hype followed by disappointment have been called AI winters. And so the reason why I really wanted to point that out is that today we do have two factors that really make this different than in the past, or at least it seems that way now. First off, big data. We're all carrying supercomputers in our pockets, generating tons of data, everything we do. We now have the volume of data to be able to use in these algorithms. And then secondly, we now have much better processing power, both our CPUs or GPUs, designated design chips just for processing. So this is now allowing us to do things we were never able to do before. And it does kind of lead us just into this, kind of high-level term then of, okay, so what really are we talking about here? And I always just want to set the stage initially and kind of define AI, since there is no real official definition, but thinking of AI as an umbrella over a few of these different technologies. So we can think of artificial intelligence, and then a subset is machine learning, and then even more of a subset being deep learning. And then when we talk about machine learning, just to keep us all on the same page, there's really three types, just to know at a high level. You have supervised learning, where you're relying on labeled data, structured data, think data in a database table. Then you have unsupervised learning, so when the algorithms are relying on training on unlabeled or unstructured data, so text in a book, using natural language processing to pull out those insights. And then finally, we have reinforcement learning. So reinforcement learning, where it's kind of taking the same approach as like behavioral psychology, where you're training the models using pre-trained data sets that are then rewarded as they process, for the correct action, the correct insights, the correct behavior. So that kind of gets us all onto, like, at least want to have a level stage, because a lot of these terms do get thrown around. And I think oftentimes when speakers get up there and we're talking about all the great stuff we're going to do with machine learning, a lot of us as developers don't even have that baseline to what are we even talking about here, okay? So the talk is called, using machine learning on iOS with IBM Watson and CoreML. And we're going to shortly get into some more of the technical details. But just as a quick show of hands, how many of you have heard of Watson? All right, of course. But, if I said now, hands up, how many could you describe specifically what Watson does? Okay, you're an employee. And the reason why I say that is, so when you look at Watson, I think it's important to understand that Watson is essentially a brand that encompasses a variety of machine learning and deep learning technologies that are across a variety of different tool sets. So we have a collection of APIs that we can do everything from visual recognition, natural language processing, speech to text, text to speech, conversation. And one of the things that is important here, specifically when we're talking about this integration with Apple, is that in addition to the deep integration that we have with a lot of different services that allow us to plug in and out and kind of build full applications pretty easily, the difference between, I think, Watson is that we focus a lot on your data being your data. So a focus on privacy, a focus on security, a focus on not using your data to train other people's models. And so I think that ties in really nicely when we start talking about CoreML and talking about a technology that one of its primary benefits is being able to run on the device itself and not being able to send and have to make requests to the cloud all the time. So in a nutshell, CoreML is a machine learning framework that allows you to, as a developer, to easily incorporate ML across the Apple ecosystem. And what it does is, you can kind of see here, it sits on top of some API collections that kind of enhance the mathematical computations and GPU and CPU. But it's really this key concept is optimizing for on-device performance. So you're minimizing the memory footprint, and you're also minimizing the power consumption, which, I talked about connectivity earlier, but that other problem is we're all running out of battery by 5 o'clock in the afternoon, right? So one of the things I want to show next is just kind of conceptualizing this just at a high level, what we're talking about. So, as a visual example, let's say a developer, provides a pre-trained, which Apple provides a collection of pre-trained models for a variety of different categories. A pre-trained model that a developer now wants to, let's say, take a picture of a cat, all right? So we have a pre-trained model that knows what animals are, and that's going to be used by CoreML. So take a picture of that cat. CoreML is going to say, hey, I know this is a cat. I'm going to classify that as a cat. Not particularly exciting, but you can extrapolate that to a lot of different problems. When we do demos, we demo, connectors. Devin's going to show you some things with some Arduino boards later. But being able to have the ability out in the field, anywhere you are, snap a picture and understand immediately what that is incredibly powerful. So as I mentioned, Apple does provide some CoreML models that have already been, or some models that have been converted to a CoreML format. And some of these include, they can be plants, animals, vehicles, people, food. They all differ in size and accuracy, and if you're going to use those, they're all on Apple's website. We have a link at the end that you can take a look at those. The only problem is that those models tend to be very general, right? Like they almost have to be. So if your use case, it works, that's great. But oftentimes, you're probably going to be able to use them for a prototype, getting your application started. But then they're not going to be actionable or specific enough to really do what you need to do for your business use case, right? And so what you then need to do is, as of right now, you'd have two options. One is you could create your own custom CoreML model. So you could do all the training yourself. You could use TensorFlow. You could then convert that to a CoreML model. Unfortunately, this takes a lot more time, and it does take some expertise in machine learning and deep learning to actually do that. And that's where the IBM Watson partnership comes into play. So instead of going off and doing that aspect of it on your own, you're now able to create a custom, in this case, visual recognition model just by uploading your images into our Watson Studio, and you don't need any machine learning programming yourself to do this. So when we talk about now benefits, you're talking about smaller sizes. You can check for updates. You can programmatically determine how often you want the model to be downloaded with any updated training. And I think Devin's going to talk a little bit more about that continuous training concepts. You can update that model without having to republish to the App Store all the time. So you're really able to separate that out, and it's a lot easier, faster, and should be a lot less expensive. The other idea here is that being able to tag and classify these images while you're offline is incredibly important, and you're saving the bandwidth and saving space on that device. So let me just show you next just a couple examples just to illustrate custom models. What do I mean by custom model? Well, we're talking about the difference between I'm going to take a picture of this tire and identify it as a wheel versus a custom model would be able to identify a flat tire. Or taking a picture and having it identified as a shoe from a general model, or having your own custom model and being able to identify it, as Adidas, okay? So those just to kind of illustrate, what we're talking about here. So now, real briefly, I'm going to cover a little bit about the training, and like I said, Devin will go in a little bit detail, but just getting the gist of how this works is that as you're out in the field, you have an application build, you're taking pictures of anything out there that's related to your model. You're taking those pictures, they're getting identified. Maybe you've built in a feedback loop to be able to say, yes, that was accurately categorized. No, it wasn't. And then being able to pass that back up into Watson, you get an updated model, and then it's downloaded to the device and used in CoreML on a regular basis. And so that feedback loop is one of the big benefits that we have here. Being able to not only be able to control how often you want to make those connections, how much bandwidth you're using, how much downloads space on the device that you're taking advantage of, and it should be a much more seamless experience and a lot easier than doing everything yourself. And so next, and this just kind of recaps that for those of you that like to think in flow charts. But next I'm going to introduce Devin. And Devin is going to get up here, and he's going to talk a little bit more about just what the code looks like, dive in a little deeper. And Devin was the lead engineer on putting together this partnership. And with that, Devin Conley.
Awesome. Thank you, Tom. So yeah, my name is Devin Conley. I'm on the With Watson Partnerships team. Shameless plug, as you can see there. And obviously worked on the integration and the engineering around Apple and Watson. So to kind of bring some of what we've talked about and some of the technology to life a little bit, we want to dive into a use case. So we will talk a bit more about the tech and the architecture behind it and what some of the model training processes look like. But for now, I want to just give you a use case that you can start to think about and use as a jumping off point. So field tech and maintenance. This is a use case that really fits a lot of the needs that we saw when we started this partnership and started working together. There's a lot of need for low latency. We need quick response time. You need a lot of efficiency in the field. Sometimes we're operating over streaming video. Similarly, you see a lot of sensitive data that you can't always ship up to the cloud. You want to keep that inference running directly on your device. And the last one, which is probably the most obvious one around field tech, is you're oftentimes operating in an elevator shaft, often a remote part of the country, in areas where you can't rely on a consistent connection to the internet. So when you start to look at an overall solution, it is not just, oh great, we can do visual recognition offline. That's a huge piece of the equation, and it's a very important part of the solution. But what you'll see is we want to pull visual insights and really take out that bottleneck. In the past, if you wanted to put together a full solution that leveraged vision, that meant you were shipping a 2 megabyte, 4 megabyte image up to the cloud. Maybe you're waiting for a 10-second round trip before you can continue operating on that in your application. With this partnership, we can now do all the heavy lifting right on the device, and we have a really rich piece of metadata that tells us part identification, the actual failure modes, etc., where we can continue to pull richer insights from the cloud and actually piece together a full solution. So from a field tech perspective, there's obvious utility for education, for the novice who hasn't seen these devices before, and suddenly a Watson model becomes a representation of the overall knowledge base of the entire org. You have senior techs who are providing feedback, and suddenly that is represented in something that myself as a junior tech might be using day to day. And then even beyond that, as far as utility to a senior technician, yeah, they're saving time because they're not getting calls all day from folks asking part numbers, for asking help on diagnosing a component. But we can also help to speed up the recording and the actual reporting as they go through their job. So we'll look at how you truly integrate tech and AI in general, honestly, into a workflow in a way that's non-intrusive and actually compelling and makes your end user want to use it. So I hope this is blown up big enough, but this is really, just let me look at the size of the flowchart, so their current state and our future state. What we want to do is we want to take the ugly diagnosis process where I might show up on site and I need to call back to a help desk. I'm in a location, someone is paying me to be there, and I'm waiting on the phone, doing nothing actionable, wasting time. That whole feedback loop of I'm going to make a call back, dig through documentation, compare against sample images. I finally know what the part is, and I know what's wrong with it. Then you're going to go through a whole second next step where you're going to do a similar flow, digging through documentation, calling a help desk, and finally you know what's wrong, and you can go through that resolution. And at the end, if you have time, maybe you'll give some feedback, back to the help desk, back to whoever's responsible for curating your documentation, and eventually maybe that feedback makes its way back into the system to help other technicians out. Under this new AI-driven workflow, we can say, let's take all of that initial diagnostics and identification work, and let's use Watson Visual Recognition. We can handle both part identification as well as fault diagnosis. Then let's connect that with another service. I won't dive too deeply into it, but Watson Discovery, which is a piece of our cognitive suite that allows you to intelligently search a large number of databases in a way that's enriched, understanding of concepts, understanding of relationships, et cetera. So it's something that we would commonly use to, say, ingest service guides or data sheets and allow those to be searchable and consumable by our end user, in this case a field tech. So you can see we rapidly speed up this process, bring them through the administrative work very efficiently, and allow them to spend a huge amount of their time actually fixing problems. And along the bottom, I want to highlight that we're not explicitly going to ask for feedback. Like I said, we want to be non-intrusive when we're asking these end users to say, hey, trust AI, trust what we're doing, buy into this process. A lot of that is about being non-intrusive. So not only fitting AI in a non-novel way, but we want it to be truly useful. But it's also a matter of when we want to capture feedback, let's do it based on, to give an example, just the way the users interact with the app. We can do, so if, let's say we were identifying a component and a senior tech is using our application and we've surfaced the top 3 that we think are likely. Yeah, a lot of the time we expect it to be our top result, and we would register that tap. They confirmed what we thought, but let's say they tap on the second best option that we've surfaced as the probable part number. Then suddenly that senior tech has provided us, without interrupting their workflow, an extremely valuable piece of feedback that we can ship back up to the system, allow an SME to review and actually continuously learn and improve on it. All right, so with that, I'll stop blabbering on what the use case should look like, and I'll show a quick live demo. So let's all cross our fingers for good lighting in here, right? All right, so let me open this up today. All right, so nobody look at my password. All right, so again, what we're going to do is we're going to say, let's imagine you're in a field tech scenario. We want to integrate with your work order system. We want to allow you to use AI to move through your job more effectively. We don't want to ask you to step into a sidecar application or go through a whole new workflow. We want to do this all online in a truly useful way. So the example we're going to look at today is around Arduino boards. And this is an open source microcontroller. It's not something that would ever be expensive enough to truly send a tech out to repair in the field, but it serves as a good jumping off point and something that you can certainly imagine extending to other components and other use cases. So what I'll do is I'll jump right into it. Actually, before I do that, I'm actually going to switch this into airplane mode just to drive home the fact that we're truly running offline. You'll see that this is going to show you part of the solution. It's not going to show you, our integration with richer insights, but it will show that we're running Watson Visual Recognition models directly on the device. So I'll start this up, and I'm looking at the component, and I'll see, all right, I've identified this as an Arduino Uno. It kicks back, tries to pull richer insights, but we're offline. Similarly, we can identify this as an Arduino Mega, which is correct here. Offline, I'm not going to get richer insights. Now we'll move to this third component, and you'll see that not only are we going to identify that it is an Arduino Uno, but we're also picking up on a failed capacitor. Now if you look at the bottom left of the board, you can see that it's a slight discoloration on that bottom left silver component, and that's what's being picked up on. So we're actually giving both part identification along with fault diagnosis live in real time, streaming at around 100 milliseconds per component, or per image. So what I'll do now is I'll flip into back online, connect to the network, and show you how, I want to emphasize again that most of these use cases, we're not fully offline, right? So even if you can do all the heavy lifting on the device, and now suddenly I have a rich piece of metadata that I can use to talk back to the cloud, pull more information, that's much more usable in 95% of partially connected use cases. So I'll go back to the original Arduino Uno, and you'll see that we're picking up, there we go. So you'll see that what's going to happen when we pick this up is it'll kick back to discovery, and it'll give you an overview and a data sheet because there's nothing wrong detected with it. So it's going to give the technician generic overview and some information about the component they're looking at. We're not going to make a call to action here. Now, similarly, if we look at the Arduino Mega, what's going to happen is we'll make a similar callback to discovery, and we'll pull up a data sheet. We'll pull up a description. We'll tell you the I/O. We'll say, hey, this is how you power the device. We're not going to give you any more information or a call to action here. So in our last case, we'll go back to the Arduino Uno where we detected a failed capacitor earlier. And what's going to happen is when it kicks back to discovery, it's actually going to pull up all the troubleshooting docs around unplugging the USB cable, heating up your soldering iron, pulling up the leads, and actually replacing the component. So suddenly we've taken this use case or this job that a technician had and said, we're going to take all that ugly administrative work around lookups, calling to a help desk, figuring out what you need to do, and that diagnostic work is reduced down to seconds. And that's something that is extremely powerful from a field tech's perspective, from a company's perspective, and from the end client's perspective to optimize their time in the field and actually bring you to do effective work productively and without wasting the technician's time. So one thing I want to show is we also, we're never going to have a perfect model right off the bat, and we don't expect to, because if you're going to go through the process of, we want to collect thousands of images and cover every single edge case and bring in 10 sets of SMEs for rounds and rounds of testing before you even launch a pilot, you're never going to get your AI to market. So what we want to do is we want to be able to position this in a continuous learning approach to start with a model that works well enough. It helps our junior techs. It can bring you through a lot of scoped down use cases. But occasionally you're going to hit a component where we haven't seen this in the field before, or our senior tech might have a more experienced opinion on a certain failure mode or something that we want to provide feedback into the system. So in this case, I mentioned some approaches earlier for capturing that feedback passively, but for the sake of the demo, I'll show you what that would look like in an explicit scenario. So here's an image I took that was classified as normal. Now in this case, it is truly a normal capacitor. You can see there's no discoloration on the bottom left. But what I could do is I could also toggle that and say, actually, I want to provide some feedback up to Watson and say this is a failed capacitor. Or you could introduce an entirely new class or entirely new failure mode if you're dealing with new geographies or new failure modes. So in this case, I'll leave it as normal, but I'll show you what that feedback looks like. So what I can do is actually, again, this would be something we want to have passively in the background, but for just demonstration, we can push that up to Watson Studio. So that image is actually now going to be populated into our overall data set sitting in Watson Studio as an unreviewed and untrained image. So what that means is you can have a non-programmer, non-data scientist who sits down in a set of tooling that is really, really consumable and easy for your standard domain expert to operate in. And they can go through, validate images, validate label suggestions, and when they're comfortable with it, kick off a new model and kick off a new training job. As soon as that training job is complete, that's something that's available for all of the devices to pull down passively in the background. So what Tom was mentioning earlier around continuous learning and making sure that you have your models synced back to the device, that's really where we start to see a lot of value add here, is that we're not requiring every single time you want to update a model, you have to train locally and push out a whole new application version to your users and ask them to download it. All these updates and the improvements to your visual recognition models, can happen in the background and on the fly at runtime. And whenever they happen to be connected to the network, there's no hard requirement for pulling a model down live to use it. All right, let me jump back to the deck quickly. All right. So to talk a little bit about the architecture so I mentioned pulling richer insights from Watson Discovery Service. I want to show you what that looks like a bit. So as you saw, there was a streaming classification of multiple models or multiple points of view on our subject matter. Right? We had one model dedicated to giving us the part identification and another model that was looking at the health of the board itself. So with those two pieces of information, you can pass that back up to Watson Discovery Service and give your end user a lot of information, pull down the relevant documentation, et cetera. I won't go through that whole spiel again. But at that point, we are connecting back to the cloud, pulling richer insights in a very lightweight and efficient way. You bring up a resolution to your end user, provide it to them, and they're going to try to make the fix. There are a lot of scenarios where, regardless of how good your tech is, it's going to be the first try, second try, and that's all part of the continuous solution, the diagnosis stage, and the collection of feedback in a passive and intuitive way. So that was runtime. And what you'll see is one of the outputs of this runtime, as you zoom in there to the overall continuous learning flow, is that we have feedback from the technician along with the images that incited that original job or that were taken at the time. And those are going to be pushed back up to the IBM Cloud or object store. From there, whenever your subject matter expert or trusted validator is ready, they can sit down in Watson Studio, make sure everything looks good as far as the data set goes, and then kick off a new model when it's ready. And then your end user, when they're back at the shop the next day, they boot up the app, they're on Wi-Fi, that model is going to be pulled down on boot up and in the background, and they're suddenly, without even thinking about it, back into the field using your latest and greatest performer. So continuous learning, it's something that's always interesting to talk about because it's a little scary. Nobody wants to push AI into the field and say, I trust the data going into it blindly and just give me the results. So there are scenarios where you truly have full trust of your validators, and you have full trust of your end users. And in those scenarios, that's fine. That's a model that you could take if you happen to fall into that niche as far as deployed continuous learning goes. But a lot of scenarios, you would probably want to take an approach that looks more like an automated validation set, where you have some 200 images that are held out, and you're treating those as your golden ground truth. You'll never ship a new model that doesn't at least meet a certain criteria against that validation set. So that's an automated way you could do it. You could take, I've mentioned SME review or a trusted validator who sits down in Watson Studio, no need for data science no need for data science or programming expertise, and they can make sure that the content that's coming into the model is good. Because at the end of the day, no matter what, you get what you train for. So the data in is absolutely the most important thing in this process. Combining those trust models, there are a few different approaches you could take. You could do a validation set plus an SME review. There are certainly a lot of approaches depending on how sensitive your requirements are and how the level of trust of your end users. So use that as a jumping off point. I do want to talk a little bit about some more scenarios, some more domains this touches. So field tech, definitely don't need to talk your ear off more about that one. It's one that we think we add a lot of value to and we're really excited to start pushing out. In construction scenarios, you can certainly imagine cases where you're doing it for audits, where you are inspecting the stock of lumber, or you need to order some more components and they're unlabeled. And that's certainly a huge time saver. You can bring someone through their job or their inspection extremely efficiently. In a manufacturing scenario, I skipped retail. In a retail scenario, there are a lot of mappings you could do back to a catalog where I have an unlabeled shirt, I have a shoe floating around, or I want to pull up similar content from a catalog and find out not only how to stock it, how do I place an order, what's the part number of that shirt. In manufacturing scenarios, you could, as I mentioned, we're getting extremely low latency. So you could easily have an assembly line whizzing by where we're inspecting components for alignment or for any kind of failures or some kind of defect. And that could all happen in real time and in a very efficient way. In service and repair, similarly to sending a field tech out into the world to do a repair on site, there are a lot of scenarios where you have devices and components getting shipped back to a shop and suddenly I, as a single inspector or a single person responsible for those repairs, need to cover a huge domain of, say, thousands of different components. And as a single person, there's no way you don't waste time looking up relevant documents and actually being able to handle that huge broad band of both failures and also device types. In hospitality, we've seen some interesting examples where you imagine you're traveling abroad or in some kind of international scenario, and you're exploring. You have no idea what you're looking at. You might be jumping from cafe Wi-Fi to cafe Wi-Fi. You could easily imagine a hotel giving their guests an application with a local model that says, hey, I can identify all these local foods, I can show you local attractions, and actually be a almost intelligent tour guide in your experience as you walk around our local area. And that'd be something that you could easily set up and say, hey, I want my concierge to each spend 6 hours one day to outfit each of our hotel locations in all these different countries, and suddenly those hotels all have their own dedicated tour guide model. So that'd be another interesting use case. So we've been talking about seamless, it's truly easy, you're flipping on a switch, but I figured probably the best way to drive that point home is to show you some code snippets, because it really is something that is, as far as model management, usage, and deploying these in a very product-ready way, the Watson Swift SDK handles a huge amount. Tons of credit to that team. So I'll show you 3 main snippets. Model management. It is one thing to be able to say, we can train this model locally, and I can ship it, package it in my application, and you can use it. But to now say, I want the infrastructure ready to train on the fly, check for updated models, pull those models down, associate the metadata, understand what's a new version, and then actually hot swap those, compile them, and have them delivered to the user in a seamless way. That's a lot of code. So that's something that we are handling in a single line. So we want to encourage a developer to say, I'm going to call this update local model function every single time my app boots up. It'll check with the cloud if we have connection, compare metadata, and only actually pull down the model if there's a new one available. So again, this is a very, very quick way to get a model deployed to your application and keep it up to date. Local classification. So if someone is familiar, anyone here with the Watson Swift SDK, this probably looks very familiar. Literally all we changed as far as using a local model versus hitting our cloud is it used to be classify, and now it's classify with local model. The data structure in, data structure out, those all look identical. So for a current Watson user who says, I want to leverage visual recognition now offline, you're flipping on a switch. All these custom models that are available in the cloud are already ready to go, if you're training a new one now. So again, very easy to actually run the inference itself. And that class variety is just the exact same string we pulled down earlier. Now this one probably appeals to a lot of folks in the room. For anyone who started with CoreML and they already have an application built out, we didn't want to make you refactor your code. No developers like to hear that I have to go back and rewrite things using a new SDK. So what we've done is we want to allow you to use that same model management and live updating functionality, but now we're going to let you just expose that as a raw CoreML model. So what you could do, if you have an existing application that uses the Vision CoreML API, you can basically add those 2 snippets, the update local model, and then you access it with a get local model. And suddenly we're handling all the model management and live updates for you, coming directly synced with the Watson services, but you now have access to that raw ML model object you can drop into the rest of your code. So it's truly, regardless of what point of view you're coming from, a Watson developer first or a iOS developer first, this is really, really easy to consume and to get started with. All right, so a new announcement that we want to talk about. At Think, which is our tech conference back in March, we announced the inception of all this, which was visual recognition, CoreML, Watson, and Apple coming together. We've now extended that. As of this past Friday, we actually have added support for CoreML deployments through our Watson Studio services. And what that means is we are not restricting things to Vision now. So anyone who has gone through the process of using any of our open source technologies, such as scikit-learn, TensorFlow, Keras, you name it, you can, as you always could, you could train, deploy at scale, and collaborate to do all that deep learning and that data science right in the cloud in a single consolidated environment. Now, beyond just the cloud-hosted deployments that we offered before, you can actually stand up a virtualized CoreML deployment. And what that means is, in similar spirit to what we were doing with visual recognition models and hosting your latest and greatest so that it is accessible to all your end users to keep them live and updated. You can now do the same thing with a totally custom, arbitrary deep learning model. So this is something we're really excited about because it's truly going to unblock anyone who needed to take their just generic data science project and productize it at scale. So I'm very excited to talk more about this one, and we'll have a lot more content on consuming it and actually getting started coming out. All right, we'll go back to Tom at this point.
All right. Thanks, sir.
Thank you. Appreciate it.
So we're just going to wrap up here. A couple things I wanted to point out. If you are interested in learning more about this, there's an Apple and IBM site that kind of goes over all the Watson services for CoreML. And then I strongly suggest checking out that second link, ibm.biz CoreML workshop. That is the same thing that we've been using this week, both for the short 1-hour workshop that was on, was it Tuesday? And then the longer 3-hour workshop this morning. So if you didn't get a chance to go through that and you are interested in diving in deeper, the CoreML workshop that they built is just fantastic. And it really walks you through step by step everything you need to know. And you can do it in your own time and run through it. So highly recommend going through it. It basically reinforces everything that we've talked about here in a really easy to use, straightforward manner. So I'll leave that up a second, snap a picture, but just ibm.biz CoreML workshop. And one other thing I just wanted to point out, you might have seen, we had a booth out front, people wearing the blue shirts. One thing IBM is doing right now, they're a founding partner of what's called Call for Code. And essentially the idea is that we're part of a group of organizations that are putting a lot of resources into this contest to be able to help potentially fix some of the more pressing global problems going on in the world. And so initially, the focus is going to be working on disaster mitigation scenarios. There's a lot more information than I can talk about right now, but there's going to be prizes. It's think like hackathon on a much bigger scale, which much larger prizes. And if you are interested in this, please feel free to stop, talk to any of the IBM folks sitting out front. They can go over a little bit more detail. And with that, I think we do have some time if you'd like to open up to any questions.
Yeah, if you guys can raise your hand so we can bring a mic to you if you have questions.
It was that good. Nobody has any questions. Okay.
Yeah. I wonder with images this looks nice, but what about not image related, like data that you want, for example, to train your model, I don't know, using accelerometer or gyroscope or something to identify some user action or something like that?
So not just visual recognition, other data.
Yeah.
Right.
Yeah, so that's something that you can do today with our Watson ML support. So any model that you're comfortable with for the specific use case, be it a structured scenario around accelerometer and IMU data, totally good to go there. You can deploy that, set up a virtualized CoreML deployment, and then your end users will be able to pull that down at the latest and greatest whenever you update it. Something like text that's a little less structured, but still a slightly different medium or type of content, exact same principle applies.
Yeah, and even outside of Watson, CoreML itself has a built-in support for their own natural language processing. So there's a variety of ways that you can kind of either between using our own stuff with Watson, and if you need to do something that custom with deep learning, but then there's also, if it's just maybe some NLP stuff with text, there's also some other options within CoreML to do that aspect of it. So.
Currently the core set of Watson services, none of those are integrated with CoreML. So at this point it is a Watson machine learning custom solution.
Right.
Okay. Thank you, everyone. I appreciate it.